From asteroids threatening Earth to innovative space stations and groundbreaking astronomical discoveries, today's episode is packed with fascinating developments in space exploration and astronomy. We'll be diving into China's new Planetary Defense Initiative in response to a potential asteroid threat, examining spectacular new images from the James Webb Space Telescope that are revolutionizing our understanding of planet formation, and exploring the progress of an ambitious private space station project. We'll also discuss the detection of the most powerful cosmic neutrino ever observed, check in on NASA's latest progress with the Roman Space Telescope, and look at an innovative new concept for lunar habitats that could change how we think about living on the moon. Stay with me as we explore these remarkable developments that are shaping the future of space exploration and our understanding of the cosmos. Let's get started. In a significant development from Beijing, China has established a dedicated planetary defense team in response to growing concerns about asteroid 2024 YR4. The European Space Agency recently announced that this near-Earth object has a 2.2% probability of impacting our planet in 2032, placing it at the top of their risk list. While these odds might seem small, they're significant enough to warrant serious attention from space agencies worldwide. The asteroid, first spotted by the University of Hawaii's Institute of Astronomy in late December, is estimated to be between 40 and 90 meters wide. To put this in perspective, while not planet-threatening, an impact from an object this size could cause significant local damage, particularly if it were to strike a populated area. China's State Administration of Science, Technology, and Industry for National Defense isn't taking any chances. They've begun recruiting specialists to study asteroid monitoring and develop early warning systems. Their approach appears to mirror successful strategies we've seen before, particularly NASA's DART mission, which successfully demonstrated asteroid deflection capabilities in 2022. What's particularly interesting about China's response is their proposed defense method. They're considering a kinetic impact approach similar to DART, where a spacecraft would deliberately crash into the asteroid to alter its trajectory. This shows how the success of NASA's DART mission has influenced planetary defense strategies globally. It's worth noting that while the threat from 2024 YR4 requires monitoring, the current impact corridor is quite wide, and astronomers will be able to refine their calculations as they gather more data. The European Space Agency continues to provide regular updates on the asteroid's movements, and multiple space agencies are collaborating to track its path and develop potential mitigation strategies. This situation perfectly illustrates how planetary defense has evolved from science fiction to a very real and necessary field of international cooperation in space science. The threat of asteroid impacts is one that affects our entire planet, making it a unique catalyst for international collaboration in space. Next up today, the James Webb Space Telescope has given us our most detailed look yet at planets being born around a distant star, offering an unprecedented glimpse into the process of planetary formation. The star system in question, PDS-70, located about 370 light-years away, has already made history as the site of the first directly imaged protoplanet. Using an innovative observational technique called aperture masking interferometry, JWST's near-infrared imager has revealed fascinating new details about the two known planets in the system, PDS-70b and PDS-70c. The telescope observed these young worlds at longer wavelengths than ever before, detecting more light than previous observations could account for. What makes this discovery particularly exciting is the evidence of warm material surrounding both planets, suggesting the presence of circumplanetary disks. These are essentially miniature versions of the disk that surrounds the parent star, and they're actively feeding material onto the growing planets. It's like watching a cosmic feeding frenzy in action, with both the star and its planets competing for the available material. The star itself is remarkably young, only about 5.4 million years old, practically a toddler in stellar terms. This gives astronomers a rare opportunity to witness planetary formation as it happens, rather than trying to piece together the process from studying mature systems. But perhaps the most intriguing aspect of these observations is the possible detection of a third planet in the system, tentatively called PDS 70 days. While this potential new world appears to have different characteristics from its siblings, its exact nature remains to be confirmed. If verified, This would make PDS-70 an even more valuable laboratory for studying how planetary systems form and evolve. These observations are providing crucial insights into our own solar system's history. When we look at PDS-70, we're essentially seeing a family photo of what our cosmic neighborhood might have looked like billions of years ago, when Earth and its neighboring planets were still in their formative stages. In exciting developments for commercial space exploration, Vast Space is making significant strides with their ambitious Haven 1 space station project. The company recently achieved a crucial milestone, successfully completing qualification testing of their station's test article in Mojave, California. With launch planned for no earlier than May 2026 aboard a SpaceX Falcon 9 rocket, Haven 1 represents a bold step toward private space station development. This initial station, while modest in size, is designed as a proving ground for Vast's larger ambitions. Haven 1 will host crews of 4 for approximately 2-week stays, with plans for 3 to 4 different crew rotations during its operational lifetime of 2 to 3 years. The station's design prioritizes efficiency, with careful consideration given to everything from crew consumables to structural integrity. Looking beyond Haven 1, Vast has even more ambitious plans with Haven 2, which they hope will serve as a partial replacement for the International Space Station after its planned retirement in 2030. This larger station would feature multiple modules, each capable of operating independently, providing redundancy and flexibility that current space stations don't have. What sets Vast's approach apart is their commitment to rapid development and in-house manufacturing. At their Long Beach facility, they're producing components in days that would typically take months through traditional supply chains. This strategy allows them to iterate quickly and maintain tight control over their development timeline. The company has also planned ahead for testing critical systems, with a 500-kilogram demonstration satellite set to launch on an upcoming SpaceX rideshare mission. This preliminary mission will validate key technologies that will be used in Haven 1, helping to reduce risk before the full station launches. Vast's progress represents a significant milestone in the commercialization of low Earth orbit, potentially ushering in a new era where private companies play an increasingly important role in humanity's presence in space. Their success could help ensure continuous human presence in orbit after the ISS's retirement, marking a crucial transition in space exploration history. In more exciting news today, scientists have recently detected a cosmic neutrino that has completely shattered previous energy records, plunging into the Mediterranean Sea with an astonishing energy of 220 million billion electron volts. This remarkable particle was observed by the Cubic Kilometer Neutrino Telescope, or KM3NET, and packs roughly 20 times more energy than any previously detected cosmic neutrino. What makes this discovery particularly fascinating is that it occurred when KM3NET was only partially constructed. With just 21 of its planned 230 sensor cables in place, the detector managed to catch this extraordinary event. The odds of detecting a neutrino of this caliber are estimated at once every 70 years, making this observation even more remarkable. For those wondering why neutrinos are so important to astronomers, these ghostly particles serve as cosmic messengers. They can travel vast distances through space virtually undisturbed, carrying information about some of the most powerful phenomena in our universe, such as supermassive black holes and other extreme cosmic events. The detection itself occurred when this ultra-high energy neutrino interacted with matter near the detector, creating a muon particle that produced telltale flashes of blue light. By analyzing the timing and brightness of these flashes, scientists could determine both the particle's path and its unprecedented energy level. While pinpointing the exact origin of this remarkable particle has proved challenging, scientists have identified 12 potential source candidates in the region of sky where it originated. Most of these candidates are active galactic nuclei, the bright cores of galaxies where supermassive black holes are consuming vast amounts of matter. There's also the intriguing possibility that this could be the first observed cosmogenic neutrino, created by the interaction of ultra-high energy cosmic rays with the cosmic microwave background radiation left over from the Big Bang. This discovery opens new possibilities for understanding the most energetic phenomena in our universe, and with more neutrino telescopes under construction worldwide, including expansions to existing facilities, we may soon unlock even more secrets about these fascinating particles and their cosmic origins. NASA's Nancy Grace Roman Space Telescope project has reached a significant milestone with the successful integration of its deployable aperture cover, essentially a sophisticated sunshade that will be crucial to the telescope's operation. Think of it as the ultimate blackout curtain, designed to prevent unwanted light from interfering with the telescope's observations of the cosmos. The sunshade itself is a marvel of engineering, constructed with 2 layers of reinforced thermal blankets separated by about an inch of space. One of these layers is even reinforced with Kevlar, the same material used in bulletproof vests, providing protection against potential micrometeoroid impacts in space. The dual-layer design ensures that even if one layer is compromised, the telescope's observations won't be affected. The integration process took place at NASA's Goddard Space Flight Center, where technicians carefully joined the sunshade to the telescope's outer barrel assembly. This outer structure serves multiple purposes, helping to maintain a stable temperature for the telescope, while also providing additional protection against stray light and micrometeoroid impacts. What makes this sunshade particularly interesting is its deployment mechanism. During launch, it will remain folded up, but once in space, 3 booms will spring upward electronically, unfurling the sunshade like a page in a pop-up book. Given that the system was designed for zero-gravity conditions, testing on Earth required special equipment to offset the effects of our planet's gravity. The successful integration marks a transition from the fabrication stage to the final assembly and testing phase. The team will now subject these combined components to thermal vacuum testing to ensure they can handle the extreme temperature variations and pressure conditions of space, followed by vibration testing to verify their ability to withstand the intense forces of launch. The Roman Space Telescope remains on schedule for completion by fall 2026, with a launch planned no later than May 2027. Once operational, it will join humanity's growing fleet of space observatories, helping us peer deeper into the mysteries of our universe with unprecedented clarity. As we plan for a permanent human presence on the moon, one of the most crucial challenges we face is creating suitable living spaces for future lunar inhabitants. A fascinating new concept has emerged that could revolutionize lunar architecture: spherical habitats made from blown glass. This innovative approach, developed by Dr. Martin Bermudez, has caught NASA's attention, earning funding through their Institute for Advanced Concepts program. Picture a gleaming glass sphere rising from the lunar surface, large enough to house dozens of astronauts while providing both living and work areas. While it might sound like science fiction, the concept leverages materials already present on the moon. Lunar regolith contains most of the raw materials needed to create these structures, including natural glass-like formations called agglutinates, created by micrometeoroid impacts. The construction process would use argon gas, initially transported from Earth, to blow the glass into its spherical shape. The vacuum environment of the moon actually makes this easier than it would be on Earth, requiring less pressure to expand the structure. The glass itself wouldn't be typical window glass, but rather a sophisticated lattice embedded with titanium or aluminum for added strength. To protect against the constant threat of micrometeoroid impacts, the design incorporates multiple layers of glass with argon-filled spaces between them, similar to double-glazed windows on Earth. The spherical shape itself provides an advantage, as it naturally distributes impact forces better than flat surfaces would. The potential applications extend beyond the moon. Similar structures could be built on Mars, particularly in high-altitude locations like Olympus Mons, where the thin atmosphere would pose less of an erosion risk. They could even be constructed on asteroids, where the microgravity environment would make the building process even simpler. While significant technical challenges remain, this innovative approach represents a promising fusion of functionality and aesthetics in space architecture. It's a reminder that as we push the boundaries of space exploration, we're not just solving technical problems. We're designing the homes where future generations of space explorers will live and work. And that's it for today's episode. Thanks for being with us on Astronomy Daily. I'm Anna, and I hope you've enjoyed this journey through the latest developments in space and astronomy. For more fascinating stories and updates, visit our website at astronomydaily.io, where you can sign up for our free daily newsletter and access our constantly updating newsfeed. You'll also find all our past episodes available for listening anytime. Stay connected with us across social media by searching for Astro Daily Pod on Facebook, X, YouTube Music, Tumblr, and TikTok. Until next time, keep looking up and stay curious about our incredible universe.